Alright guys, so we're moving into chapter 2, and this first lesson is going to be about quadratic equations. Some of this should be a review and some of it may be new. These are our goals for the day. So we are going to, I'm actually going to make this an extra credit opportunity, and I'll talk about that when I get there. So derive and use the quadratic formula. Solve a quadratic formula, or solve a quadratic by completing the square and the quadratic formula. This may be new. Understand and use the sum and product of roots, and then understand the discriminant. This may also be new, but you may have done this last year in Algebra 2. Okay, so let's look at the first two questions. So we want to solve the quadratics with the quadratic formula, and then one with completing the square. Now, the easier way to solve a quadratic with the completing the square method is always going to be when your a value is equal to 1. Okay, so we'll go through some different examples of how to do that when a is not 1, but if a is 1, that's the easier method to use. So we're going to do completing the square over here on this side, and quadratic formula for the left problem. Okay, so quadratic formula we all know and love is x equals negative b plus or minus root b squared minus 4ac all over 2a. Okay, so my a, b, and c values here, okay, I have to have this set equal to 0, and this equation is, so my a value is 4, b is negative 12, c is 9. Okay, so I'm going to go plug these values into the quadratic formula. Alright, so x equals the opposite of b plus or minus root b squared. I'm going to go ahead and do that. So negative 12 squared is 144 minus 4 times 4 times 9 all over 2 times 4. Okay, so I want you to take a minute and try to simplify that on your own. Okay guys, so it ends up simplifying to 0 underneath the radical. So this one is really nice because this radical just ends up going away and leaving me with 12 over 8. And so my final answer for this quadratic is 3/2. Now, completing the square. Completing the square has a few different steps. So we're going to go through those in detail here. So what we're going to do first is make sure that this c value is on the other side. Okay, so I need my a, so this is in ax squared plus bx plus c form. So I want my ax squared and bx terms on the same side, and then I want to move the c value over. Now at this point, I'm going to go ahead and find the b value. Okay, so the next step is for us to take the b value, divide by 2, and square. Okay, so for us, that means 1. 1 is our b value. So 1/2 squared gives me 1/4. And then this is the value that I'm going to go ahead and add to both sides. So I'm going to add 1/4 to both sides, and that's why I leave this space here when I move the c. Now, at this point, you should always get something here that is factorable, that you can factor into 2 of the exact same factor. So if I think about this, x and x is going to have to be what goes first. And then this last number right here, I'm looking for numbers that multiply to give me 1/4, but also add to give me 1. And that's going to happen to always be this number that you had right before you squared it. So think about this. So 1/2 times 1/2 does give me 1/4, which is what I want them to multiply to. And 1/2 plus 1/2 gives me 1, which is what I want them to add to. So 1/2 and 1/2 is what I need to use here, and both signs need to be plus. And then for this, I'm going to think about negative 2 with a denominator of 4. So I'm going to say, okay, negative 2 is the same thing as negative 8 over 4, plus 1 over 4, so I get negative 7 over 4. Okay, so my answer so far is this. So now I can take and write this as x plus 1/2 squared, since I have 2 of the exact same factor. And then to solve, I'm now just going to take the square root of both sides. Now, this side is going to give me an imaginary number, and I'm going to actually simplify this a little bit first. So the square root of 7/4, or negative 7/4, is going to look like this. Okay, so square root of the top, square root of the bottom. So I have x plus 1/2 is going to equal positive or negative. I'm going to bring out an I, and then it's root 7, since root 7 won't simplify, over 2. Okay, because the square root of 4 is 2. And then my last step is just going to be to subtract this 1/2 over. So negative 1/2 plus or minus I root 7 over 2. Since both of these have a common denominator, you may see this written with the tops combined. So negative 1/2, or negative 1 plus or minus I root 7 over 2. Okay, so there's our final answer from there. Now, for this, if you want to schedule a time to work through how you would derive the quadratic formula using completing the square, then we can set up a time to meet to do that, and that'll count as some extra credit. So if you're interested in that, just email me or text me and let me know. Now, the next thing that we're going to look at is the discriminant. And the discriminant is a pretty familiar thing. Hopefully we realize what this is or where it comes from. So if we think about the quadratic formula, this is the quantity that's under the radical. So this is under the square root in the quadratic formula. And the discriminant can be pretty helpful. So if I know what this quantity is and how it relates to 0, I can use it to tell what type of solutions a quadratic is going to have. Okay? So for a quadratic that has a discriminant, or b squared minus 4ac, that's greater than 0, or positive, a positive discriminant, what that means is I have two real solutions, and my graph of the parabola is going to look like something maybe like this, okay, where it goes through the x-axis twice. Okay, a discriminant that equals 0 means I have one real solution. And so on the graph, if I were to graph this, it would look something like this, maybe a parabola like this, where it only touches one time on the x-axis, okay, or it lies tangent to the x-axis. That's another way to describe what's happening there. Okay, and then if I have a negative discriminant, okay, something that's less than 0, then I have two imaginary solutions. And that graph is just going to look something maybe like this, where the graph never crosses the x-axis. Okay, so those are the options for what my discriminant could tell me. Okay, so for this first example with talking about the discriminant, we want to figure out how many real solutions there are for this equation. Okay, so for that I need A, B, and C. So A is 1, B is also 1, C is negative 1. So I want you to go ahead and plug this into b squared minus 4ac and tell me what that is and what that means for the number of solutions. Okay guys, so for this one, hopefully we worked out our discriminant, and it is 5, and that means we have two real solutions. Okay, so two x-intercepts for this parabola. Now, a problem like number 2, so we want to find a value for k such that this quadratic has exactly one real solution. And what that means is that my discriminant, okay, so if I have one real solution, my discriminant is going to equal 0. Okay, so b squared minus 4ac has to equal 0. So what I'm going to do is look at what a, b, and c are here. So a is 1, b is root 2, and c we don't know. Right now it's k. And so I'm going to plug these values into the discriminant. So I'm going to say, okay, b is root 2, so b squared, minus 4 times 1 times k. Alright, so let's work this out. So root 2 squared is just 2, minus 4 times 1 times k is going to give me 4k. And so now I can figure out what this value for k is by just solving this. So I'm going to add this 4k over. So that's going to give me 2 equals 4k. And then when I divide by 4, k is going to be 1/2. Okay. Okay guys, so For this one, I kind of want you to try this one on your own, okay? Because this is kind of leading you to the product and sum rules for the roots of a quadratic. So we want to find the roots, okay? We're going to do that by factoring, so I want you to try to factor this and then tell me what x equals. Those are the roots. When you find those, take the product of those roots and then the sum of those roots and see what you get. Okay, so hopefully you were able to factor this and get that the roots, if we solve both of those factors, set them equal to 0, we get -4 and -2. Now the product of these roots gives us 8. The sum of these roots gives us -6. So what do you notice about C, or about this 8, I just showed you the answer, in our equation right here? Okay, so hopefully we notice that the 8 that we got for the product is the same as the C value here. Okay, so the C value is the product. Okay, and the sign of this is exactly the same. It's +8 here, it's +8 here. Now, our -6 is similar to what our B value is, but it's the opposite. Okay, it's the opposite of what we actually have in our equation. And this is something that's going to be true for every quadratic, so it's kind of nice. Okay, so here are those rules just kind of summarized. So if we have a quadratic, okay, this x squared plus bx plus c, then the product of the roots, okay, so r1 times r2, the product of the two roots is going to give me c, and the sum of the two roots, they're going to give me the opposite of b. Okay, and that'll be the way that it happens every single time. So we're going to do an example really quickly that looks at how to use this. Okay, so if we are given roots of a quadratic, we can actually go find what the quadratic is that would give us these roots. Okay, so we're going to use the sum and the product to find the actual quadratic that we have. So let's go ahead and find the product of the two roots. So the product of the two roots is going to be when I multiply 1 plus root 5 over 4 times 1 minus root 5 over 4. Okay, so if we multiply this out, the bottoms are pretty easy to multiply. 4 times 4 is 16, but the tops I'm going to have to actually FOIL these out. But they're pretty nice because these are conjugates, what we call conjugates, where one is plus and one is minus, but otherwise they're the same. So what's going to end up happening is when we FOIL, okay, we multiply these out, 1 times 1 is 1. The outsides and the insides cancel. So the outsides give us negative root 5, insides give us positive root 5, and those are going to cancel. So really all I need to do is just multiply the first and the last. So the last terms are going to give me minus 5 here. So I end up with -4 over 16, which reduces to -1/4. So this is like my C value. Now the sum of these roots, I'm just going to take 1 plus root 5 over 4 plus 1 minus root 5 over 4. Okay, so when I add these already have a common denominator, so that's nice. The positive root 5 and the negative root 5 cancel, and I end up with 2, which reduces to 1/2. And so this is the opposite of B. Okay, so my B value is actually going to be, I'm going to make it -1/2. So my quadratic that results is going to be x squared minus 1/2 x, and then minus 1/4. Now, most of the time you're not going to see those fractions left in your quadratic, so a lot of times what you're going to see done is this whole equation multiplied by 4. And so what this is going to do is create a quadratic that has the same roots, but that will not have fractions. So if I multiply by 4, I get 4x squared minus half of 4 is 2, and 1/4 of 4 is 1. So here's the quadratic that would have these roots. Okay. All right. Really quickly, I'm going to just do, I'm going to have you try number 1 here, and then I'm going to write the answer down. Alright guys, so we're going to go over this more in class, but I know the area is length times width, so I just plugged in my dimensions and then set this equal to 0 and solved with the quadratic formula and got my length and width here.